All right, let's dive right in. Today, we're going to talk about one of the most powerful tools the human mind has ever created. We're talking about deductive reasoning. So, let's get this engine started.
Think about it for a second. How can you be absolutely sure of anything? In a world that's just swimming with opinions and guesses and maybes, is there any way to get to a conclusion that is 100% lock solid, guaranteed to be true? Well, that very question is exactly where our story begins. For basically all of human history, we've been on this quest for certainty. And this wasn't just some casual thing. This deep need for proof is what led us to build a formal, structured way of thinking, a method for building knowledge on a foundation you could actually trust.
This whole idea really kicks into high gear back in ancient Greece with Aristotle. He's the guy who took philosophical arguments and basically turned them into a science. He built a system to prove things, not just argue about them. And that system, it got a major upgrade during the Enlightenment, becoming the core of science. And today, it's literally the bedrock of our modern world. We're talking math, computer code, the legal system, the whole shebang.
And sitting right at the heart of that entire system is this powerful machine we're here to understand. We call it deduction. And you can really think of it as a finely tuned engine built for one job and one job only, to produce certainty.
So what is it exactly? Well, deductive reasoning is what you'd call a top-down process. You start with a big general rule, something you know for a fact is true. Then you take that big rule and apply it to a very specific situation. And if you follow the steps right, the conclusion you get isn't just likely, it's a sure thing. It's guaranteed.
The source material really just nails it with this phrase. See, deduction isn't about discovering new ideas or making educated guesses. It's about proving what must be true based on what you already know for sure. It really is the logic of proof.
The magic trick behind this whole engine is a really cool concept called truth preservation. It's a simple idea, but it's incredibly powerful. It's a promise that says, if the ingredients you start with, your premises, are true, and the recipe you follow, your argument structure, is valid, then that truth gets preserved all the way to the end. The conclusion that comes out the other side is absolutely, positively guaranteed to be true. No doubt about it.
Okay, I know this might all be sounding a little bit abstract, a little academic, but the truth is we use this kind of logic all the time, especially in places where being certain is, kind of a big deal. So let's look at a classic example from the world of law. Okay, let's break it down. Step 1. We start with a general legal rule. All valid contracts have to have something called consideration. That's just a fancy term for an exchange of value. So that's our first premise. Step 2. We look at a specific case. This document, right here on the table, it doesn't have any consideration. That's our second premise. Now the deductive engine kicks in and bam! The conclusion is inescapable. This document is not a valid contract. It just has to be true.
And really, this is the foundation of so much legal thinking. Judges are supposed to take those big, general laws and apply them consistently to the unique, specific facts of whatever case is in front of them. Deduction is the tool that makes sure the system is fair and predictable, and not just based on someone's gut feeling that day.
Now, to really appreciate what deduction can do, it's super helpful to look at what it doesn't do. It's a very specialized tool in a much bigger toolbox of how we argue and reason. The biggest comparison you'll always see is with induction. If deduction is the logic of proof, then induction is the logic of discovery. So, for example, induction is when you see 100 swans and they're all white, and you form a theory, hey, maybe all swans are white. It's a probability. Deduction, on the other hand, would start with the rule, all swans are white, to prove that a specific new swan you find must be white. So one is for discovery, the other is for proof. And of course, deduction is totally different from things like rhetoric, which is all about the art of persuading people, or sophistry, which is when you're using tricky, bad logic to try and fool someone. Deduction isn't trying to sell you anything. It's just showing you a truth that can't be escaped.
So, at this point, we've got this perfect engine of certainty, a system that guarantees truth. It sounds completely unbeatable, right? Well, this is where the story takes a really humbling and honestly a fascinating turn.
Because in the 20th century, this brilliant logician, Kurt Gödel, came along and proved that even our most perfect system of logic has, it has limits. And this right here is the mind-bending takeaway from his work. This was a bombshell.
Gödel proved that any logical system that's powerful enough to be useful, like for doing basic math, will always have statements inside of it that are true, but that the system itself can never ever prove. It's like reason itself has a built-in blind spot. There are some truths that are just beyond the reach of formal proof. So you have to ask, right? If our best tool for finding certainty isn't perfect, why does deduction still matter so much? What's the point?
Well, here's the thing. Even if it can't prove everything, it's still the single most powerful tool we have for building reliable knowledge. It's the absolute bedrock that lets us create mathematical theorems, design the software that runs our world, and structure our entire legal system. It takes simple truths and lets us build these huge, complex, stable systems that we rely on every single day.
And that brings us to our final thought for today. Deduction is the closest we've ever gotten to true certainty, but we now know it isn't perfect, it isn't complete. So we want to leave you with this question. If even our most rigorous, perfect engine of logic has limits baked right into it, what does that tell us about our endless search for absolute truth? Thanks for watching.